series. There are many situations where we're actually interested in finding the sum of a term, the sum of the number of terms of a number sequence. We call that a series. So like if I had a sequence that was 1, 4, 7, 10, dot, dot, dot. So that's a sequence, an arithmetic sequence to be precise. To make that a series, or an arithmetic series, all we have to do is add those terms. And now you have a series. So that's all a series is. Instead of listing them, you add them. So we could do a finite series where you just add the first 3 or 4 terms. We could do an infinite series where you add up until the end of time. So we're going to cover both those cases. First, sigma notation. A series could write it more compactly as a sigma notation or summation notation. So instead of writing all of this out for a time, we just write it in a sigma notation. So that's what this notation here is. So if you see something like this, right, that's called sigma notation. The E right there is it's a symbol for sum. So like adding, right? How we add these terms? That's what that E says. If I see that E, I'm like, oh, I'm adding these terms. The way this generally works is, this is where you start. So we start with our first term, then we substitute it into the equation, so we get U1, and then we're going to go U2, U3, and we're going to keep on doing this up until we get to the top term. That's where we stop. So dot UN. And we just add them all up, and that's how it goes. So that's what this notation means. It just means, hey, start down here, plug it into this equation until you get to the top equation, then stop and add them all up. Because that's what the E stands for, is adding them all up. So first example here. Consider the sequence 1, 4, 9, 16, 25. Write down the expression S of n. So I want us to write down the formula. So we're going to write like this. Looks like we're starting with our first term, U1. So you use any variable you want. We'll say k equals 1. Now, in this case, we're going on forever, so top here will be infinity. The problem is we got to come up with an equation right here. So that should be an equation, U sub n. And let's look at this one. Go 1, 4, 9, 16, 25. Now, this isn't an arithmetic or geometric series. Because look, it's going plus 3, plus 5, plus 7. So it's not arithmetic. It's not geometric, because it'd be multiplied by 4, multiplied by not 4. What this is, if you notice it, this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So really all it is your term squared. And that's our formula for this one. It is, I mean, my E could be better, but k equals 1, k squared, until the end of time, infinity. So that's how you write it down. Find Sn for 1, 2, 3, and 4. So let's do for each one. So S of 1, so that's just the sum of the first one. S of 1 is always just the first term. So 1 squared, which is 1. Right? That's all S of 1 is, just the first term. S of 2 means I want to add the first term and the second term. Well, the first term would be 1 squared, and the second term will be 2 squared. So I just get 5. S of 3 means add the first 3 terms. So 1 squared plus 2 squared plus 3 squared. Again, in this term, each term is just square it. So first term, second term, third term. I guess I just added these right there. That would have made it just as easy. So I get 14. S of 4, again, I'm going to add the first 4 terms. I have the first 4 terms right here. So it'll be 1 plus 4 plus 9 plus 16. And that'll be 30. And then S of 5 would be 1 plus 4 plus 9 plus 16 plus 30. Sorry, plus 25, not 30. Let's go ahead of myself. Now the way I do this is if you notice, 1 plus 4 plus 9, I already knew what this was. That was 14, because it's based off right there. So I just added the extra term here. So for this one, I know when I add all these up, that's going to be 30, because I did that earlier. And so add the 25, so I get 55. So that's what S1 is, just the first term by itself, 1. S2 just means add the first 2 terms, 1 and 4, so you get 5. S3, S4, and so on. Now let's evaluate this using sigma notation. So remember what this means. So we're going to start at 1. We're going to substitute into the equation. So my first term is just plug 1 in. So I get 1 plus 1, which is 2. My second term, so I'm plug 2 in. So 2 plus 1 is 3. U3, 3 plus 1 is 4. U4, 4 plus 1 is 5. U5, 5 plus 1 is 6. U6 is 7. I'm just going to go U8. So U7, sorry, is 8. Right, so those are all my terms. And now remember what the E means. And the reason I stopped at 7 because that's what the number on top was. All the E means is add them all up. So to find this, I'm just going to add 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So let's see, 2 and 8 is 10. 3 and 7 is 10. 4 and 6 is 10. And then we have 5. So I get 35. So that's what that is. It's 35. Next one, I'm going to list it out, and we won't add it. I'm going to use a calculator actually to do that, but we'll list it out, right? So if I see this, I should never not know what to do. It's like, okay, you want me to do this? All I'm going to do is plug the first number in, 1/2. Plug the second number in, 1, 2 squared. 1/2 cubed, 1/2 to the 4th, and you keep on doing this until you get to the last number on top, 2 to the 5th. So you want me to add all these up, and whatever that is my answer. I'm not going to do this by hand. I'm going to use a calculator. So here's our calculator. So first I'm just going to do it like the way it shows. So 1 divided by 2 plus 1 divided by 2 squared plus 1 divided by 2 cubed. Gotta go down, plus 1 divided by 2 to the 4th. And this is exciting video watching here, I know. There's a reason, I think. So I get all this, and I get that. And let me put it in fraction form. So math fractions, this for the sake of it. It's probably a little easier, right? So this is 31/32. So that's what we get when we do this summation. Now I want to show you can also use your calculator to do the summation if you have an updated calculator. So I'm going to go to math. Toward the bottom should be a summation. So you can see right there, it has the little E, says summation on it. And then look at it. Look how beautiful this is. You just type the way you see it. So you press X. Only variable we have is X. I guess you could use the alpha to do the other ones, but we'll just use X. 1. I want to stop at 5. And this is going to be, I'm going to do my fancy fraction alpha. And it's going to be 1/2 to the X power. Then we hit enter. And I get 31/32. So that's how I do it with the calculator or technology. So you just find the summation, plug it in the way you see it. Some properties of summation. Now when you see a summation like this, so the sum of this sequence plus this sequence, you can break it up to some of these sequences. If you see a constant there, you can pull it out. So that's what happens here. Expand the summation k equals 1 of 2k, then write the expansion again underneath it, but with terms in reverse order. So they want us to write this thing to the n of 2k. So again, that'll just be 2 times 1 plus 2 times 2 plus 2 times 3. I'm going to go ... here plus 2 to the n. Now they want us to write it again in reverse order. So if I wrote in reverse order, it would be 2 to the n plus, now how does this work? It'll be the one before this. So it'll be 2 times n minus 1 plus 2 times n minus 2 ... and we start off at 2 to the 1st, like this. So like that. Add the terms vertically and hence write an expression for the sum of Sn for the first n even terms. So this would be 2 plus 2n. This would be, I gotta distribute 2n minus 2, this is 4, so I get 2 plus 2n. If I distribute this, I get 2n minus 4, and I get 6, so add them up, you get 2 plus 2n. ... and you get 2 plus 2n. Now, I want to add all these up. Now, how does this work? Keep in mind what happens when you add up. Let's say I get 2 plus 2 plus 2 plus 2. Another way to write this is 2 times 4, right? Because you're adding the same thing 4 times. So 2 times 2 is 8. 2 times 4 is 8. That's the idea. So here, we're writing 2 plus 2n n times, right? Because we're going 1 to all the way to n. So like that. Now there's one problem here. Since I wrote them front to back, now I have two versions of this. I like doubled it up, so I undouble it, divide by 2. So I get that. I guess if we want to simplify, it could. Right, because I can factor out 2 from that, so it'd be 2 times n 1 plus n over 2. So cancel out, and I get n times 1 plus n. distribute, and you get n plus n squared. So that's a sum of n equals 1 of, what's the formula? 2n total n. So that's a shortcut to it. And that's the lesson.